So, all right, trigonometry. So, trigonometry.
No, me and him are actually really close. Yeah. That was a joke.
Trigonometry. Okay, it comes from the measures within a triangle. These are going to be the ratios of the sides in a right triangle. So when we do trigonometry, it's going to be within a right triangle.
We're gonna say hi. 3, 2, 1.
Hi,
Jaden, Maya, and Roz, and
Hello.
no one else.
No,
Justin's
Justin.
right there. Justin's right there.
Hello.
Hi, Jaden, Maya, and Roz, and Peter.
I need that. Just do this. Because I gave Jonathan my portable charger, so I can't charge it from that.
Okay.
Hi, Jaden. Hi, Roz.
Hi, guys.
Maya.
Hi.
All right. Trigonometry. Ratios within a right triangle. Okay, so let's say we have a triangle ABC, and C is the hypotenuse, right? Because that's always opposite the 90-degree angle. Okay. We are going to look at what's called the sine of A, the cosine of A, and the tangent of A. So if we locate, here's angle A. Okay, now these are the abbreviations, but you'll never hear me say sin A or sin cos. So I'll always say the actual word, sine of A, cosine of A, or tangent of A, but we abbreviate with the first 3 letters. Okay, now a ratio is, a ratio is just a comparison of 2 numbers, right? It's something over something. That's all the trig ratios are. They're just going to be 2 numbers divided by each other. Okay, so let's talk about the 3 different ones. So sine of A, here's our abbreviation. So it's going to be the leg opposite angle A over the hypotenuse. So here's our triangle. If you look directly opposite angle A, we're going to use a lowercase a. So you'll notice opposite the capital letter represents the angle. The lowercase letter is going to represent the side. So if I said, what is the sine of A? We'll say A over C. So if I gave you actual numbers, like let's say this was 2 and this was 5, I would just say sine of A is 2 over 5.
Is that, but the leg opposite A is just A.
Yeah.
Leg opposite. And the hypotenuse is just C.
Well, okay, so here's another quick example. I could have asked you what the sine of B would equal. So sine of B would be the leg opposite angle B, which would be little b, over the hypotenuse. So I can choose a different angle, okay? I'm looking at different sides. So sine is always going to be the opposite side over the hypotenuse. So next we have cosine. Cosine is going to be the leg adjacent to angle A over the hypotenuse. So looking here, adjacent means next to. Which leg is adjacent to angle A? It's B. So this is adjacent over hypotenuse. So it's going to be B over C. So it's going to be okay. It's 3 ratios.
Wait, but let's say it's angle B. Which one would be adjacent?
A.
So it's never the hypotenuse.
No, so notice this always says leg adjacent. Leg opposite.
Okay.
Because the
Okay.
what did it say?
Okay, we're not ever going to do sine of the 90-degree angle, not until you get to algebra 2, okay? We're not going to do the cosine of 90 degree. We're always going to do the acute angle, all right? Okay, the last one, this one's tangent. Tangent of A is going to be the leg opposite to angle A over the leg adjacent to angle A. So that's A over B. Okay, so let me just, I could give you an example. Like, let me give you a completely different, let's just say this is, I'll say this is X. I don't know, what numbers? 5, 12, and 13. So if I said, what is sine of X? We would look at opposite is 5,
13.
over the hypotenuse is 13. If I said, what's the cosine of X? Do the adjacent side, which is 12, over the hypotenuse. And then if I asked you what's the tangent of X, that's going to be the opposite over the adjacent. Good? Okay. Now, some students have a hard time remembering the order, like which one's opposite adjacent. So we have this SOHCAHTOA. I know, funny word. So the first one stands for sine, is opposite over hypotenuse. Sine is opposite over hypotenuse.
Okay.
And then cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay, so far?
Oh.
Okay, so we're going to first do sine, cosine, and tangent of R. So here's R.
What's A?
Wait, can you go back up for a second?
Oh, sure.
Oh, adjacent.
A is, okay, so A always stands for adjacent, O stands for opposite, H stands for hypotenuse. Okay, in relation, okay, so don't worry about S for right now, just look at R. So with R, the opposite side would be the 4.
4 over.
The hypotenuse would be the 5. And the adjacent side will be 3. Does everyone see that?
And then it's 3 over 5.
Okay, so 3 over 5 for R.
Tan would be 4 over 3.
4 over 3.
Oh, it's opposite adjacent? And then 3 over.
And then cosine, it's opposite over adjacent. And
Cos
then
is 3 over 5.
cosine is 3 over 5. Okay. Now, if I want to look at S, so now if I'm referring to this angle, now my opposite side is 3 and my adjacent.
Is it sine 4 over 5? Yeah, you wrote 3 over 5.
Did I write the wrong thing? Oh, it's 4 over 5. Yeah, sorry.
No.
Wait,
Sine.
no, wrong way.
Other way. Yeah,
Oh.
4 over 5.
Did I write the wrong thing? Oh, 4 here and 3 here.
And then isn't it
Sorry about that.
switched for sin?
Yeah, so now if I do sine of S, it's going to be 3 over 5.
4 over 5. And then 3 over 4.
So these two are always going to be the same. These two are always going to be the same. And what's going to happen with the tangents? They're always going to be reciprocals. I have in here write it as a fraction and as a decimal, but we'll just leave it as fraction.
Wait,
for now.
now we need our calculators.
Now we're going to need our calculator. Okay, so first thing, okay, the first thing we need to do is make sure it's in the correct mode. Okay. If someone else had been using your calculator from a different class, they might have a changed mode, but in the top right, you might see RAD.
Wait, no.
Yeah,
I
okay.
don't see it.
If it says DEG, perfect. That's actually what we want.
What if I saw mine's
So we need to change this.
Oh,
We need to change this to degree. Now there's a couple ways.
You just-
If you just hover over it and
now
click
it's
it,
DG.
it'll change to
Oh,
DEG.
what is-
Now,
That's
if you
the
hover,
Oh, it's a whole nother answer.
It is a completely different answer.
Wait, why? How does that work?
Okay, so
What is that? Just gives you like radical.
So, okay, in math, right, we have things like centimeters and inches, right? I can measure this desk, the length of the desk. I can measure this with a ruler in centimeters, and I can also do it in inches. Is it different? Is it going to be a different number?
No.
I mean, is it going to be the same length, but is the answer going to be a different answer? Yeah. So radians is a different way to measure angles, and we don't need to worry about that until algebra 2. Okay? So everything that we do in this class is going to be in degrees. In degrees. Okay?
I found it.
So now it says specifically we want to round to the nearest 10,000th place, which is pretty small, 4 decimal places.
Oh.
Yeah?
60 degrees is easy.
Okay, so you're going to, does everyone see the trig button?
Yeah, I found it.
And you literally just type in, right? Just select sine of 57 degrees, press enter.
It's so easy. I got.
Did you just hear me?
I got that.
Okay, so that's going to be 0.8387. Okay, cosine of 60 degrees. 0.5.
Wait, why did you do points? Wait, no,
Oh, you're
guys,
degrees.
you're going too fast.
Okay, make sure you're still in degrees.
No, like, mark them.
Okay, and then for
You're
10,
five.
for 10 Miss cases, it's 0.57.
So let's go.
3,
0.57.
0.5774.
3,
4.
4 if we're rounding to that
And then
fourth.
the next one is
0.9962.
0.962.
Yeah.
Okay, so everyone's like, where do these numbers come from? Where do these magically come from? Well, we just, they come from similar triangles. Okay, let me start with the cosine of 60 degrees. Now we just finished doing 30, 60, 90 triangles, right? Do you remember the relationship between, like, if this is the shorter side, what's the hypotenuse? 2x. And this is x root 3. No matter what the x is, right? So if I said, what's the cosine of 60 degrees, right? You would say that would be the adjacent over the hypotenuse.
That's for code.
Cosine is adjacent over hypotenuse.
Oh, and sin is x radically.
What do you notice? The
over.
x's are going to cancel.
Is this for any right triangle?
This is for any right triangle. Okay? All right, now we're going to actually use these values of sine, cosine, tangent to find the value of x. Okay, so first step, I want you to identify the angle that you're working with. You don't have to circle it, but sometimes in the beginning I just circle it. That's the angle I'm going to work with. Are you cool enough now, Zoe? No? Okay. All right, what side are we trying to find? X is the, you can't close it.
Adjacent.
You want me to get it? Is it wet? All right, X is the opposite side, and 19 is the adjacent. Okay, according to our SOHCAHTOA, I have to decide what I'm going to use. I can't use sine or cosine. Why can I not use sine or cosine?
Because you don't know the hypotenuse.
I don't know the hypotenuse. Do I have enough information to find the hypotenuse? No, I can't even do Pythagorean theorem.
It would be x
So-
over.
Tangent.
It's x.
Okay, so I'm going to write tangent of 24 degrees equals, okay, it's got to be equal to the ratio of x and 19. Okay, now I'm not going to type tangent of 24 into my calculator yet. I want to just plug it all in at one time. I'm going to isolate the variable, which means I need to multiply both sides by 19. Okay, on the calculator,
19.
yeah, do 19. So 19 times tangent of 24.
I got 8.45.
Perfect. Okay. So we're gonna round the final answer to the 10th place. So that's gonna be
So
In the video,
just
can
be
you see the
x
calculator?
8.5. X equals
8.5.
Wait, so it's 9. Wait, what do I plug in my calculator?
19 times tangent of 24.
Would it be around?
We're gonna round it, yeah. Now, of course, if I wanted to find the hypotenuse, now I could do Pythagorean theorem because now I have two sides, right?
Oh.
This is, so now x is 8.5. Does that answer make sense? Yeah. Okay, next one. Now I'm going to use this 62 degrees. This time, I know the hypotenuse. So I know right away it's going to be sine or cosine depending on the other side.
It's going to cosine.
Yeah, this is adjacent here. So I'm going to use cosine this time. Cosine 62
equals x
over
28.2.
Oh my goodness. Okay. So we're going to multiply both sides by 60. So now we're doing 60 times cosine of 62. Yeah, it just takes a minute to type it all in. 28.2.
Wait, so we know if it's sine or cosine or tangent, whether
It's
if we have the
in relation
hypotenuse,
to the angle.
if we have the hypotenuse, then it's sine or cosine.
If we have the hypotenuse, or we're trying to solve for the hypotenuse, we're going to use sine or cosine.
But if we do not have the hypotenuse, then
Yeah.
it's tangent.
Let me just, you know what? Actually, I think we'll have time. I forgot to add in an extra example, but that's okay. We'll do it when we do the worksheet. Okay, use a special right triangle to express each trigonometric ratio as a fraction. Okay, tangent of 30. So I want you to just make a quick sketch of a 30, 60, 90. So this will be x, hypotenuse would be 2x, and this is x root 3. Okay, right? This is our little 30, 60, 90 triangle. Okay, now 30 degrees.
How do you know it's 39? Oh, yeah.
30.
So it has to be a right.
Okay, I want tangent. Okay, tangent is opposite over.
Over
Adjacent.
It's x rad 3.
So it's x over.
X
over x
over x rad.
Okay, so these will cancel. So I have 1 over root 3. But remember, our rule is we don't want to leave a square root in the denominator.
It's
One
1 rad 3
Or just
divided by
root 3
3.
over, just root 3 over 3.
Okay, multiply.
Because you got
It's opposite over adjacent. Okay, Jonah, let's step it up.
No, I'm just charging.
All right, now, sine of 60 degrees. I could either draw my picture over again, or I can just now look over here. Sine is opposite over.
Hypotenuse.
So what's opposite of 60?
X rad 3.
X
rad
root.
3 over 2x.
And what's going to happen with the x's?
We're going to cancel. It's rad 3 over x.
Over 2.
I meant that.
All right. Any questions so far?
Wait, so that's like the answer?
That's the answer.
Oh, this sucks.
All right.
I would not be able to do this one.
Well,
We say that every time and we get 100 on every.
Okay, inverse trigonometric values. Okay, when we use trig equations, we can also find the angle. So far, I've always given you the angle measure. But what if we want to find the angle? Okay, so what we can do,
I was wondering why they had the -1. There.
there's a -1. This is called the sine inverse. Okay, it's so what ends up happening is the sine inverse and the sine cancel each other out. It's kind of like, let's take like an algebra equation. Like let's say I had 2/3 x equals 6, right? So do you remember the multiplicative inverse? Remember that?
What?
Okay, inverse just means reciprocal.
I thought that's converse.
No. we would multiply by the inverse to
I've
solve.
learned this. I hate it.
So all we need to do here is multiply, or not multiply, but take the sign inverse. So we get A equals, now we're going to, on our calculators, you're just going to select the one below the sign, right? So we're going to type in sine inverse of 0.4325.
Wait, sine inverse
What is this equation thing that you did?
of 0.
Do we have to do whatever equation thing you just did, like every single time? Like, what is this?
Wait, did you do sine inverse?
Yeah. Enter. 25,
There you
26.
go. That's right.
You did.
So is that what it equals?
Yeah, that's what the angle equals, 25.6 degrees.
Wait a second.
Wait, so why did you have to do all this sine? Why couldn't
Okay,
you
we're
just-
not going to do that. I just wanted to show you that from the very beginning,
Oh.
because what we're doing is we're taking the sign. Remember, it's still an equation, right? So whatever we do to one side of the equation, you have to do the other. So the reason I do this is these will cancel each other out. So angle A is going to be equal to the sine inverse of this. Now, I
So
never
we do
write
not
this
have to
out
do,
all
okay,
the
so
time.
we just,
So whenever I see this, I just do sin negative
Okay.
times the thing.
When do you use the little -1? We always use that when finding the angle measure. So A is equal to tangent inverse of 1.1.
do we have to write that out?
Yeah, this part, just write this out.
Oh, but that's like.
Listen, everything. This is just plugging it into your
It is not
calculator.
as bad. Sin minus 1.
Oh, but this one's tangent. Oh, or are
No,
you
I
doing
did
the
not.
second one? Did we get an answer for this one?
No, wait, what? Oh.
Wait, how do you know when you're finding the inverse and when you're finding
Right here. Use
It's-
the inverse whenever you're finding the angle measure.
Oh.
Oh,
Okay,
so
this
if
is
it
an
has,
angle
if it
measure.
has the dot.
Yeah.
1,
Anybody get it yet?
Yeah, I'm doing it now.
7, 6. It's 54. A equals 54.800.
Good.
8.
Okay, and then B is the sine inverse.
Wait, why is it
Let me
B?
try
Why
that
is
one.
it not A?
Because I
This is B.
Does it matter?
So you just chose.
just have, listen,
Sin
it's just a variable. I'm just
0.6307. 39.1018.
good.
39.1.
0.6.
Okay.
39.1.
We got this. We're almost done. This is the last page. Okay. Find the,
Oh, I
Can
leave
you
that.
go back up?
Yeah,
for a
sure.
second?
okay, find the value of x.
No, actually I'm not.
You're free.
I'm going to.
Did you do
Okay.
over Jason?
Yeah, so x is what I'm solving for. 15 is opposite. This is adjacent. So that's how I know I need to use tangent. Ladies, shh.
Did you cancel things?
Yeah.
I got that in the mail.
Okay,
In
so
the mail? They sent those out?
okay, you guys don't understand what it means when I say shush.
Oh, okay.
We got to work on that. Okay, tangent inverse. I mean, when we're done and you're working on homework. Okay. Now, if you want to reduce this, go for it. It's fine. I actually don't need you to even worry about doing that. Okay. Again, how did I know I had to do the inverse? Because I'm trying to find the angle measure. Okay.
Yeah.
Oh, yeah.
So whenever I'm finding the angle measure, I'm going to use the
And
inverse.
then whenever
button.
you're finding the side, you're going to use regular.
How do you do?
Did you get 68.1?
I think it's 6. I think if we round, is it
0.2.
0.2?
Wait, so.
Okay, so now this one, we're going to do, this one is,
Cost.
Do you have all the answers?
Yeah.
Are you looking at the answers?
No,
You have
this
them all
is
memorized?
tan.
This is tan.
this one's tangent again,
7 over 13.
is 7 over 13. So x is equal to tangent inverse of 7/13. So again, there's not a lot of math, like computational, that we're doing, but I do want you to show
just
the
a
setup.
calculator.
I want you to show these 2 steps, okay? And then just from here, you just plug it into your calculator.
X equals
What do we got?
7/13.
And that comes out
28.3.
28.3 degrees. Good.
Now you don't use the inverse.
Right, this is going to be the regular one. So this is now, oh, it happens to be tangent again.
Tan
Tangent of 64,
of 64 equals.
opposite.
Whoa, how is 11 hypotenuse?
Oh, I'm sorry. That's
Oh.
supposed to be adjacent.
It's
There we go.
tan.
Isn't it tan of x? Are you doing like?
No, it's always
What?
sine, cosine, and tangent are of the angle.
Wait, I
yeah,
forgot how to do this.
Wait.
one.
Okay, how do you isolate
Oh,
x?
times 11.
Multiply both sides by 11.
X equals.
So 11 times tan equals 64. 64.
Not equals 60.
22.5.
Times.
22.6.
22.6. Okay, last one.
It would
So,
be
adjacent.
cos.
No.
Adjacent over hypotenuse, so this one has to be cosine. 41 degrees.
Wait, how did you get cos?
Because it's adjacent.
So look at the 2 sides we're working with.
Wouldn't it be x over 32?
X over 32.
So it would be x.
Look, it can't be sine, because sine you would have to be
Yeah,
working with the opposite. And it can't be tangent, because I also don't have the opposite. So cosine's the only option, and then we're
Can
gonna
we do it? 32
Sure.
times cos. No. Cos 41 equals 20.
24 point
24.1502.
Bro.
24.2.
Yeah.
Wait, what?